two-way tables are something we learned about last fall early, and we had stuff, and then more stuff, and maybe my stuff was a 5 and a 3 and a 2 and a 1 and a 7 and a 9 for my more stuff. And then we had row totals. So 6 and 10 and 11. And then we had hang on to that word, column totals. And that little thing in the corner we called that the grand total, although that was more our word really than what I've ever read, but that's kind of what it is. The grand total is all of these bits in here added up. Now, these are your margins, your marginal values. What did we call the stuff inside? Anybody remember? That's data. It is the joint. Thank you. That was the word I couldn't come up with either. Joint frequencies. Awesome. You just pulled that out of your notes? Yeah. I'm impressed. I'm impressed, Cooper. These are the guys that we care about today. The total rows we're not going to use in chi-square, but they may turn up in your data. So this is these are our observed. They're the joint values. Okay. Yay. We can move forward. So remembering that, or thinking about that, chi-squared uses matrices. Now, if you were in Math 1 Honors, you should have looked at matrices. And I think Math 3 maybe dealt with matrices too, did it? A little bit? Heck if you remember. Really? So the good news is we are not doing a lot with matrices. If you don't understand matrices, it's okay. You can survive this, no problem. You do have to know how to get into it though, so we'll cover that. Chi-squared degree of freedom also comes into play, but we've got basically what's going on now is instead of having two columns, which is goodness of fit, we've got as many columns and rows as we want. Okay, that's what chi-square does. It allows you to do any number of columns and rows. So degrees of freedom then becomes rows minus 1 times columns minus 1. So what are we testing for? Because it is a test. The question is there a significant difference in one or more categories or groups from what's expected? That's really the question we want to answer. Is there a significant difference in Right? Everybody good? Okay. So, on the TI-84, which I think everybody has, use matrix. And to get to that, we're going to go second and inverse of x, which is, I think, just underneath the math on the left side there. And we're going to input in matrix A for the observed group. I'm not even going to give you the formula to do this longhand. Okay? We're not doing it. That, and it's, you've got a tool here that'll do it for you. It's solid. I know it if I, look it up, sure. Okay? So, the expected, why would I do extra work if I don't expect you to do it? The expected is created automatically in matrix B. Or wherever you tell it. Usually it's B. Okay? Sort of the default. Earlier I mentioned that knowing if you've met all the conditions was a problem because all your expected counts have to be 5 or more. So basically what you have to do is you have to do the test and then come back and look at matrix B to see if you met the conditions. So the condition, meeting of that condition kind of has to happen a little bit out of order. You don't have to write it that way, but that's what it does. So let's look at an example. A survey of 490 college students at a Southwest State University So in those 490, we have freshman, sophomore, junior, senior. They were asked if they had body art. Body art. And we're going to test this at alpha is 1%. Apparently, this is a life or death question. Okay? I think it's funny because it's changed. It'd be like, years ago it'd be like, you're going to get a tattoo? And now it's, what tattoo are you going to get? Right? Things have changed about that a lot. So, if you don't get a tattoo, you're like in the minority, I think, these days, right? Michael, I don't have time right now. We got to finish this problem up. Royal's not in this. Oh yeah, he is normally in this class. Where's Royal? He should be. Ditcher. So we've got grade that they're in, piercings, tattoo, both, or none. And piercings, as I recall this problem, are not ear piercings. unless they're, you know, something odd like gauges, right? I say odd, but maybe it's not all that odd. Those have kind of fallen out of fashion, I think, yeah? So we've got our grades, and here are our numbers: 61, 43, 20, 21 of those grades have piercings. Tattoo, 7, 11, 9, and 17. And both and none. Wait a minute, let's see. 61, 68, 78. Yeah, you're right. There's less people that have piercings or tattoos than that don't in the freshman class. What a bunch of losers. Okay, so these are your observed values. These are your observed. The null hypothesis here. Anybody want to take a crack at it? That's essentially it. They're all the same. We're going to write it a little differently. In this case, we're going to take it as a proportion problem because it would be piercings out of total and so forth. So we're going to say proportion of freshmen equals the proportion of sophomores equals the proportion of juniors equals the proportion of seniors. Isn't that pretty much just saying they're all the same? I think if you wrote that our proportions are all the same, then you'd be in good shape. Okay. The alternative.
It doesn't equal.
There is a difference in at least one proportion. Yeah.
What's the point of that? Because you know that it's not going to equal.
But is there a significant difference? Right? Yeah, it's probably not going to equal, but is it significantly different? That's what we're looking for.
Don't laugh at me.
And we're saving that for tonight.
Oh no, that wasn't bad. That was a mean joke.
Yes, it was. Actually, if you crack us all up, is that really a bad thing? Assuming you intended it.
The point is I'm not intending.
Oh, okay. Well then I'll try not to snicker or laugh. How's that? Okay. So degrees of freedom.
1 minus your six.
Right. 4 minus 1, the number of rows minus 1, times the number of columns minus 1. So row minus 1, column minus 1, which is going to give us 3 times 3 is 9. Okay, have our conditions been met? Is it reasonable to assume that this would be a random sample? Is it reasonable to assume that there's probably at a large or at a Southwest State University, there's probably 5,000 students-ish that they could pull from? Okay. Is each group at least 5 or more?
Yes.
Oh, wait a minute. We don't know that yet. Because these are our observed. It's the expecteds that we have to look at. So we can't really say if we've met that condition yet. Let's do our input here. So here's what we're going to do. You want to go to matrix. So that's second and the key right below math, the inverse. You want to go over to edit. We'll edit A. This does need to be a 4 by 4. It looks like, I'll double check it, but it looks like I've got my numbers in here already. If you don't, that's okay. You just type over what's there. So 61, and it goes by rows.
So like the way you wrote it?
Exactly. You put it in just like this. Yeah. But it puts in as rows. So
This is tricky. So it does everything for you.
it does everything for you.
That's crazy. Life's crazy.
This class would be a nightmare without these calculators. I don't know that I'd be teaching it. I don't know that I'd be smart enough to teach it.
Give yourself
I think I am.
some more credit.
Oh, okay. So we put that in. Some of you maybe already had it, yeah? Lucky. So once you've got that in, we quit. And we're going to go to test. So stat, tests. We want just the chi-squared test, which is kind of towards the bottom. Choose the chi-squared test.
Do you really repeat?
You don't need to. It does it automatically. So observed is going to be your matrix A. This is the matrix. How you can choose that, if you need to, is you can go second and matrix, and then you can choose whatever you want for that. So like, let's say I wanted it to be C. I can put that in there, but I don't. I want A. The expected, you can put that wherever you want. B is just fine. It's going to build that for you. Okay? And then we're going to calculate. You can draw it if you want. I don't really mess with that too much because it doesn't usually ask for stuff like that. So chi-squared. I'm going to say that it's a test, and my observed was A, matrix A. Expected. B. Chi-squared is 29.5-ish. P-value, oh, that's quite big, isn't it? No,
Yes.
very small. It's
Oh,
a
no.
probability. It can't be more than 1. .0005 is probably just fine. Or .001, you could do that. And it gives degrees of freedom. We actually calculated that, but there it is. So we'll go back and look at that condition here in just a second. Would we reject or fail to reject based on that p-value? Reject. Yeah, for sure. That's less than any reasonable alpha. And our alpha in this case was 1%. They gave us a really low one. So this would be a reject the null. And so there would be a difference in one of these groups. Michael, 1 second. Let's look and see if we met our condition, though. We need to look at matrix B. Now, it made it for us. So to do that, I'm going to go back into the matrix. And to look at a matrix, you have to go to Edit. Otherwise, it won't show it to you. And then I'm going to go B, and there are my numbers. Now, if you're doing this for an AP test, I read in the book, it recommended heavily that you write these values in. Okay? That you can't just say, hey, I looked at B. You actually kind of have to like write them. I wouldn't write the whole thing with all the decimals. I would do some rounding. Frankly, I just rounded B matrix, something like that, and list it. But none of these values can be less than 5. Did we meet our conditions?
Yes.
Yeah, everything's 5 or more. So
It has to, no matter what.
no matter what.
No, or just this problem.
No matter what. That's that's a condition.
Oh. And
All
then
your expecteds have to be 5 or more.
this is just what it'd be like if they were equal.
Yes.
Okay.
That's what, this is what we expect based on what's given. So the expected values are going to be 61 divided by the total in that column. I'm pretty sure that's how that's going to be 43 divided by the total, 20 divided by the total, 21 divided by the total. Or maybe, no. Yeah, I forget how to calculate those. I know that I've seen that before, but it's probably not all that important. All right, I want to take a look at another problem.